All right, today we're going to talk about average rate of change, which is section 2.4 and 2.5. And we're going to look at different things regarding slope. So the first thing, find the average rate of change is what our goal is. And then we're going to determine if a function is even, odd, or neither. So if you recall, the slope of a line is simply found by subtracting the y's, dividing by subtracting the x's. In other words, we're going to find the change in y over the change in x as it relates to chemistry symbols, remember? Triangles mean change in. So we're going to find the slope, just practice here. So quickly, 6 minus negative 2 over 1 minus negative 3 is 8 over 4, which is 2. Simple. Just finding the slope like we did probably 2 years ago. Slope-intercept form, just a reminder, y equal mx plus b. M is the slope, b is the y-intercept. So let's go through this question right here and kind of talk about what this rate of change means. So a sub shop purchases a used pizza oven for $875. After 5 years, the oven will have to be replaced. Write a linear equation giving the value V of the equipment during the 5 years it will be in use. So what assumption does the second sentence make? After 5 years, the oven will have to be replaced. Well, to me, that means it's not going to be worth anything, right? So after 5 years, it's worth nothing. So if it cost $875 now, and then it costs nothing in 5 years, and so it'd be $875 minus 0. And let's see, we divide by 5, right? Because it's 5 years in use. $875 divided by 5 would be $175 per year that it would depreciate. So that would be negative $175 per year. So what would the value be? Well, you'd obviously have negative 175 per year, we'll call it X. And it started out at 875, and there's our linear equation. So we can relate this to a line. Why is that important? Well, that leads us to the average rate of change, which is real-time things that we're going to talk about. It is slope. It is found by finding the slope, but it is not slope like we think of. It means something. So like miles per gallon, that's slope, but that's average rate of change. So temperature change, that's the average rate of change over a month's time or a year's time or something like that. So when we find the average rate of change, we can find it on any curve. And the average rate of change is the slope of the secant line between x equals a and x equals b on the graph of f. That is the line that passes through a f of a and b f of b. In other words, I have this graph right here, and let's say I'm going to pick this point, which is a f of a, and this point, which is b f of b. This line right here is called the secant line. The slope of this secant line is what we call the average rate of change between these 2 points. So it's very useful. We can see how the population of deer is growing. We can look at the average rate of change of costs of things. So it has many, many values. You might also see f of b minus f of a be known as the net change in the value between x equal a and x equal b. I think our book uses that notation. So here's a good problem. For this function, x minus 3 quantity squared, we got a graph down here. Find the net change and the average rate of change between the following points. Well, the net change from 3 to 1 is 2. That's easy. So now we're supposed to find the average rate of change, which is f of b minus f of a all over b minus a. Well, we just found b minus a. That was 2. What is f of b? Well, that would be right here between 3 and 1. That's 0. So f of 3 is 0. Get you minus, what's f of 1? Well, it looks like f of 1 is 1, 2, 3, 4. Looks like to me. So f of 1 is 4. So the average rate of change is negative 4 divided by 2, which is negative 2 between 1 and 3. So now let's look at the average rate of change between 4 and 7. Well, your net change now is 7 minus 4, which is 3, which we can put down here. What's the average rate of change? Well, I need f of b minus f of a. And it looks like 7 is 16, f of 7, and f of 4 is 1. So that's 15 over 3, so it's 5. So the average rate of change is negative from 1 to 3, but positive from 4 to 7. Okay. Okay, so now let's talk about even and odd a little bit. Even and odd functions are simply, you have functions that are even, odd, or neither. Okay? So they're either even, or they're odd, or they're neither one, and we don't really care about what we're going to call those. So don't panic if they're not even or odd. So if we do this then, for each x in the domain of f of negative x equals f of x, so that's even. Here's what it means. I'm going to put it in graphical terms first. If you take your calculator and you have an even function is going to reflect on the y-axis. That means it's even. So if you take it and fold it, it's going to look the same, folded on the y-axis. That's if you're going to do a graphical analysis of it. Now, a graphical analysis of an odd function, it is symmetric about the origin. And what that means is you're going to take your calculator, graph a odd function, and if you flip it upside down, it looks the same. Now we're going to look at these algebraically. So algebraically speaking, to test whether it's even or odd, you're going to put in the opposite of x. The opposite of x is negative x. You're going to evaluate it. If you get the original function, then it's even. If you get the opposite of the original function, it's odd. And if you don't get either, then it's neither. So for instance, here we go. To figure out even or odd, we're going to plug in negative x instead of x. Well, negative x cubed is negative x cubed. But you can see that the x cubed is opposite, yippee, but the negative 5 is not opposite. And it's not the same, so this is neither. It's not even or odd. Because if this is the opposite, if x cubed, if that's negative, then the negative 5 would have to be plus 5 in order for it to be odd. To be even, it would look exactly like this. So let's try B. Plug in negative x. Okay. So you have negative x square root of 1 minus x squared. Now, is that the opposite of all of this? The negative? I think it is, isn't it? So this would be odd because it's the opposite. Wasn't expecting that when I looked at the equation. And finally, on C, we're going to do negative x and plug negative x in there. So negative x to the fourth is still positive, and that's going to become positive. Oh, we got an opposite again, don't we? Opposite, well, no, we don't. This isn't opposite, but this one is. But this one's the same. So this is another neither. It's not opposite, and it's not the same. When I say opposite, that means every sign has to be different. The reason this sign does not have to be different is because we're multiplying inside here. Okay, maybe we can find an even one here. And maybe we can't. Let's see. So it'd be negative x quantity squared plus 2, which would be x squared plus 2 all over negative x. Now, algebraically speaking, we could put the negative out in front. Is this and this, are those opposites of one another? They are. So this is odd again. Trying to think if we have an even. We don't have an even, do we? There's not an even on here where we get the exact same thing. So what could we do to find an even function? Here's an easy one for you. X squared. If you type in, or if you plug in negative x in there and square it, you get the same thing. So that would be called an even function. Okay? All right, thanks for your time, and